Hello, everyone, and welcome to Must Know Machine Learning Concepts. And this is lecture or lesson number 8. So, if you haven't watched the first 7, go back and do that. Here, we're going to talk about data. We're going to talk about structured data. What is structured data? Why is it so important? We're going to talk about unstructured data. Why is it important? We're going to talk about the differences between the two. What's the difference between structured and unstructured data? We're going to talk about SQL, the king, used in almost every data store imaginable. We're going to talk about how much SQL. There's no such thing. Plus, that's your answer. When someone says, how much SQL do I need to know? I said SQL plus. That means you just keep learning SQL. There is never enough. Pipelines. We're going to talk about pipelines. What are pipelines? Why are they so important in machine learning? Well, if data is the king in machine learning, which it is, it's the king. That's the crown. Then what are pipelines? Pipelines are used to move, guess what? They're used to move data around the organization, right? That's what a pipeline is. All right, so we're going to talk about, lastly, underlined it, we just talked about it, data is the king. Yes, it is. What is structured data? Structured data is tabular data. Here, tabular means table. Here's a table. It's got columns and rows. This is structured data. Think of an Excel spreadsheet as structured data. Think of a table in a relational database. This is structured data. This is about 80 to 90%. That's a percent symbol of all machine learning in the real world. So structured data is tabular data. Think Excel spreadsheet, think table in a relational database. Data that has structure that's not tabular is unstructured data. Right? Think of an image. Here's a picture, right? That picture has structure. There is structure to it, but it can't be easily massaged into a table. So if whatever it is we're talking about can't be easily jammed into a table, then it's unstructured data. So what about an audio file? Audio file, right? That certainly has structure to it, right? We can see the audio file structure to it. Not tabular structure, though. So it can't be easily moved into a table. No, it can, but not easily. All right. How about text? Now, this isn't interesting. Text documents. Text does live in tables. However, text documents for NLP, we'll call this a doc file, right? A doc file, like a Word document, can be fed directly to a machine learning model that still needs to be in the form of an array, but it's not necessarily tabular in nature. All right. How about an HTML file? Have you ever seen HTML? HTML certainly has structure, or we couldn't have the internet. However, it can't be easily massaged into a table. All right. So we have two kinds of data. We have structured data, we have struct, and then we have unstruct. All right. Almost every data store that exists has a SQL front end, and some of it, and most of it actually, uses SQL as the core language to access the data. So all relational databases, they use SQL. Relational databases. And there are millions of relational databases in corporate America and around the world. Millions. How about data warehouses? Data warehouse. Yeah, we'll pretend I'm a doctor for now. Data warehouses. What do they use? Yes, all of them use SQL. How about big data stores? Guess what the front end for most big data stores is? The front end for these data stores, right? That aren't necessarily tabular data. Guess what? They have a SQL Front end. We've already said that most modeling in the real world is done with tabular data. And that means you must know SQL. Must. It's a requirement. I mean, how much SQL? There's never enough, right? You can never know enough SQL. This idea that SQL is easy and that somehow you can learn it in 6 weeks is what novices say who've never worked in the real world. There's nothing easy about SQL. All right, and SQL is not just SQL. SQL also really means, when I say SQL, I mean you need to know about relational databases, relational DBs. You don't get to know SQL without knowing relational databases. It's not how it works, right? You connect to relational databases to pull the data out. This is where the data is. This is the data. If you don't understand the data store, no one gives a shit how well you know SQL, select, or insert statements. You're going to have to know the structure of the database in order to use SQL. Never enough. And I've been working with it for 30 years now. And I still don't know it well enough. Data pipelines. Most role of machine learning is data cleansing. It is cleaning data, I promise. It's to the tune of 80% or more, and I promise you it's likely more. Well, guess what pipelines are? Pipelines are nothing but moving data. What do you think we're moving? We're moving data for the cleansing process. Right? We're just not moving data, raw data. We'll just move this raw data from here to here. Right? Now, you can do that, and a DBA or data engineer may do that, but that's not why an ML ops person creates data pipelines. They're creating data pipelines for the cleansing process. Step 1. Step 2 in the process. For each step, they're doing something. Maybe here they're removing columns or attributes. Maybe here they're doing mean value mutation. And they're doing this so this creates a repeatable process for everyone in the team to do. So ML Ops is really mostly this. Working with data to create data pipelines so the entire team can have clean data. Data is exponentially more important than any model. Right? Machine learning is data. It really is. The model is irrelevant. Now, that's not necessarily true. I'm saying this to make a point that the data you have, the amount of data, the cleanliness of the data, the completeness of your data is more important than the model. Because if you have data, if you have the right amount of data and it's cleansed correctly, you can use a lot of different models. Now, in the real world, we're going to use XGBoost because it's going to give us the best outcome for our regression plus our classification problems, which is most ML, most machine learning, right? But doesn't mean you have to use XGBoost. I mean, there are people that are great at feature engineering that might use deep learning on this data set and beat the XGBoost model because they are great at feature engineering and they've cleaned this data even further, right? So the king, if you know anything about Kaggle, you'll know the king of Kaggle, and all those that do really well in Kaggle are feature experts, feature engineering experts. They're not modeling experts. This idea that they do better with models is nonsense. They aren't. All right. The best Kaggle people are they're data people. They know data. All right. So what do we do in this lesson? We talked about structured data, what it is. It's a table. It's tabular data. We talked about unstructured data. It's not. It's not. Not tabular. Not tabular. Not tabular. Not easily jammed into a table. All right. We talked about the king, SQL. All data stores. Never worked at a company that didn't have a data store that didn't use SQL. There you go. All data stores I know of or have ever worked with use it. Use it. More SQL. There's never enough SQL. Again, you don't just know SQL. It's not just learning SQL, the language. Select, update, insert, delete. That's not it. It's really knowing relational databases. Relational databases. All right. What are tables? How do you create tables? How do you define what's in the tables? What are data types? What are the keys? How are these tables related? All right. That's not necessarily SQL, but you have to know that before you can use SQL. We talked about creating pipelines and what they are. Pipelines are nothing more than data cleansing steps or ways to move data across the organization for the ultimate goal of modeling that data, of modeling that clean data. That's what data pipelines is. And lastly, we said data is the king. It is. Data is exponentially more important than the model. All right. Thanks for watching. Thanks. And have a great day. We'll see you soon. I created LogicBot for 2 reasons. One, to help people transition to a machine learning engineering role that are already in a data role. And in a data role, I mean heavy SQL. Number 2, train those who aren't in an entry-level role as a data analyst. The data analyst is the only entry-level data role I know of. Companies are looking for skills. You either have them or you don't. You either understand what certifications are and their importance, or you don't. The truth is, you don't have that many options. Companies are looking for very specific skill sets, and without them, you're not going to be working in any data role. There is a recipe, and you must follow it if you want to work in any real-world data role. Then move to data engineering or machine learning engineering later on. LogicBot has that recipe. You need to follow it and learn the skills and gain the certs necessary. It's that simple. Thanks for watching. Don't forget to like and subscribe and have a great day. We'll see you soon.